Now that we know how to get the simple linear regression model and find our best fit parameters using least squares, let's talk about how we can interpret the result of our model. So sometimes you'll hear this prediction task of using least squares regression as regressing y on x. So suppose we fit a model, we're going to gather data that takes random cats and measures their weight in pounds and their length in inches. And let's assume we're randomly selecting cats of a certain type of or a certain species. We're not just all over the board with the cats. So suppose that this is the equation we get out at the end, that the predicted weight is 2 plus 1/2 the length. This is just a made up model. How can we interpret that 1/2? So let's think of it in terms of units. It's measuring the increase in y for a unit increase in x, right? Okay, but now how can we translate that to the data that we started with? Does this mean that if a cat in the data set grows 1 inch, we estimate they'll actually get 1/2 pound heavier? Or if not, what does it actually mean? So take a minute and think about that. So the answer is no, because let's think about why. The model that we created was based on data that we collected in a snapshot, or from a snapshot of several cats. We were not looking at snapshots of the same cat over time. That would have been called longitudinal data. We did what's called cross-sectional data. And yes, we do see association in the sense that this is not 0. This slope is non-zero, so there's some type of association, but I can't conclude causation. So the best interpretation here is to say if 2 cats have a 1 inch height difference, their estimated weight difference is about 1/2 pound. That's what we can conclude from this number. Now I'm also going to point out that we have to be careful about the scope. So I can't use this to predict on wildly different data, right? So if I trained this on domestic short hair cats, I can't use this to give me information about, say, the Maine Coon, right? Because that's a totally different ballgame here. So this won't necessarily work outside the scope of the data that you used. So these are important things to keep in mind when you're interpreting the coefficient in your model.